In this video, we're going to talk about topic 5.6, determining concavity of functions over their domain. We're going to answer the questions, how do I determine the concavity and points of inflection for a function? And I can determine the points of inflection, and I can determine the concavity of a function. So when we are working with graphs in calculus, you want to think of them as roller coasters. The x value is where you are standing on the boardwalk. And the y value is the height of the roller coaster track. The derivative is the slope of the roller coaster track. And the second derivative is the concavity, or the curvature of the roller coaster track. To figure out the concavity of a graph, use your hand. If you put your hand on the graph and your palm is facing down, then the graph is concave down. If you put your hand on the graph and your palm is facing up, then the graph is concave up. A point of inflection is the point on the graph where its concavity changes. I'm not spelling that right, concavity. It's basically when you turn your hand over. So what we're talking about when we're talking about holding your hand on the graph, I took a couple of pictures here. So you'll notice that my palm of my hand is always touching the graph. And do you see how my hand is curving? This is something that is concave down because it's curving down. I like to say it's concave down like a frown, right? And then this here where my hand is still, I had to flip my hand over. It's kind of awkward to do this. I had to flip my hand over, and now I am concave up like a cup. I would be able to hold water in it. Okay, so let's take a look at a couple of examples here. So in this example, so the graph of f is sketched above. Find the values of x, which the graph is concave up, concave down, and has points of inflection. So this is extremely in general. We would not see, this is just to understand the idea of concavity. So if I am looking for concave down, I am looking for where my hand would be upside down on this. So it looks like I am definitely, I'm looking in this area here approximately. So it looks like I would go negative infinity, and then I would stop, it looks like at about, I don't know, like not quite 2, right? About 1.7 maybe. And with concavity, we use open intervals always. All right, and then we are concave up like a cup. And that would be happening on from about 1.7 to positive infinity. And then our point of inflection happens when this change occurs. So my point of inflection would be at about x equals 1.7. All right, looking at example 2. I'm going to try to identify my points of inflection first. Let's try that. So that way I can kind of get an idea of where it's changing. It looks like we've kind of got to change about right there and maybe about right here maybe. So point of inflection at x equals, it looks like about, I don't know, about 2. We could fudge it to 2, right? And then this one looks at about 5. All right, so now let's talk about concavity. Let's do concave up first. So I need it to hold water, or my palm of my hand, if I use my hand, would be facing up. So it looks like it's going from negative infinity to 2. And let's see where else. It's like there's 2 of them this time, from 5 to infinity. And then concave down, we're definitely in this upside down area. It looks like it's going from 2 to 5.